Good afternoon, everybody. This is a live recap of our DERECHO event and windbag event, plus fast-moving wildfires that happened on December 15, 2021. Absolutely unprecedented event for that time of year with the DERECHO. Looks like over a dozen tornadoes. The preliminary reports are over 30. Preliminary straight-line wind reports of over 500. In this video, I'm also going to break down how those QLCS tornadoes can be identified. I'm going to explain the occlusion process. You can look for those little cuts right along the gust front. I'm going to explain where we targeted the elbow or the knee of that DERECHO. Basically, the little pivot point is the area to target because that's the area where the most likely tornadoes can happen. I'm going to explain why as well. A very unusual shape to this upper level storm system. It had a strong negative tilt as it was punching toward the upper Midwest. There you can see that ejection of that haboob there that moved from southeastern Colorado into southwestern Kansas. A big dust storm or a haboob with even little convective elements on the top, little gustnados feeding into that haboob. And then as the wind continued to progress from west to east across the high plains, there were wildfires in Guymon, some evacuations down there. Thankfully, that didn't come in to the Guymon, Oklahoma area there in the Oklahoma Panhandle. But then another fire got going in north central Kansas, just to the north of Russell, driven by 80, 90 plus mile per hour winds, even gusts up to 100 miles an hour, straight line winds happening. And there you can see in the water vapor as that dry air ejects behind that front, eventually firing those storms that developed first in north central Kansas, and then those progress off to the northeast. And this is an incredible composite image here. This was created by Jack Sillen, a very talented meteorologist. Definitely give him a follow on Twitter at Jack Sillen, Sillin, produces some incredible images like this. And look at this composite radar image. It shows the development of that DERECHO there in north central Kansas. That is a fast moving arc of embedded supercell structures. It's a QLCS, or a quasi-linear convective system. So it does have little supercell structures embedded within it, but they are joined with a gust front that surges out, and any of those kinks within the line are capable of producing tornadoes. And you can certainly see that elbow as well that I want to discuss right now with this DERECHO composite. First of all, a quick look at all the preliminary reports from the Storm Prediction Center, even showing those severe wind reports there in the high plains of Colorado. Even a little bit of a shower would mix down those 90 to 100 mile per hour winds and then become severe. Whether it has lightning or not is definitely an issue when you do have severe thunderstorm wind gusts, but a shower without lightning still capable of mixing down those destructive winds. You can see most of the tornadoes existed in two different corridors as well. And that's right along the elbow or the knee of that DERECHO. And now I'm going to break down this beautiful composite image here from Jack Sillen and show you exactly where that elbow progressed as it lifted off to the northeast. And I'm talking about the pivot point here. You can see a little pivot point that develops down right near the Nebraska-Kansas border and then continues to progress off to the northeast. You can see these swaths, these tornado reports that are right along the progression of that elbow. And anywhere to the northwest of that pivot point, you had a little bit more in the way of those supercell structures, and then a little bit to the south of that pivot point where the winds were more parallel to that advancing boundary. Then you had a little bit more of some linear configuration to that QLCS, but still those embedded tornadic circulations all the way down, even just near the Omaha area, as you had the initial elbow that tracked in on the north side of the system, and then another elbow or a kink in that line right at that pivot point. You can call it a knee, call it an elbow, but basically the likelihood of a kink or a mesocyclone forming within that line right at that pivot point, basically the track of a mesolow all the way up. That's the greatest likelihood of getting those tornadoes. And interestingly, the upper level shape to this storm system was a little bit different. So normally when you have a closed 850 low and you have those winds, those 1 kilometer winds wrapping around on the north side of the pivot point, you get more of a southeasterly or an easterly component to those low-level winds. That's what happens when you get a closed 850 low. And in that case, these likely would have broken off and become long-track tornadic supercells to the north of there. But because the 850 low was relatively open, the 850 winds didn't really wrap around to the north of the pivot point, and your best shear nosed all the way up to that elbow region. And that was where you had still some backed winds just to the east, right near that pivot point. But you also had a little bit of directional shear with that low-level jet ejecting off to the south. But right on that nose, that's where the nose of low-level shear pokes right up to that elbow or that knee. Also, the instability, the better dew points and surface temperatures, warmer surface temperatures would also nose right up to that pivot point. So you had the best co-location of those ingredients right along the elbow or the knee, and that's why you did have those two swaths of tornadoes, one with the initial elbow off to the northeast, and then you also had tracks of tornadoes along the original elbow, the new elbow, as it cycled a little off to the southeast. Some of these tornadoes produced EF2 damage as well in western Iowa. Some homes that were destroyed down there, but that's the knee or the elbow, that pivot point that I've been talking about for the last couple of days, and that's why you had those two swaths of those tornadoes, QLCS tornadoes. And I'm also going to show you exactly how to identify those QLCS tornadoes as well when they're about to happen. Here you can see the water vapor loop showing you just how high. This is satellite imagery that shows you where that arc it was ejecting into western and central Iowa. Dry air back behind it. That's infrared. Not the water vapor. And it does show you how low-topped and tilted that convection is along that advancing arc. Here is some other satellite, almost behaving like a sting jet or a scorpion tail punching in behind it. You can see that convection that developed first in north-central Kansas and then tracked into south-central Nebraska. It did produce a pretty decent tornado near the Marquette, Nebraska area relatively early in the convective cycle. That line was moving so fast that we decided to wait until the line approached to the south of Norfolk. But that big tornado, that large cone, happened to the southwest of Columbus, Nebraska, near the town of Marquette, right at about a little after this satellite image. So this shows that convection developing in north-central Kansas, the wind bag coming in behind it. A little bit of condensation and drying happens right at the tip of that tail as it's ejecting behind that arc. That's a scorpion tail. Almost looks like a sting jet type of a deal happening. And fire danger did end up materializing. We did discuss that extreme fire danger leading up to this event. It happened really up and down that swath, that hatch area for that extreme fire risk from the central Oklahoma Panhandle all the way up to north central Kansas. That fast-moving wildfire just to the north of the Russell area ended up killing a bunch of cattle as well, destroying some livelihoods up there, very sadly, with those cattle ranchers to the north of Russell. Thankfully, it didn't come into Russell itself, but there's a lot of farms, a lot of communities to the north of Russell that very sadly were impacted by that fast-moving sting jet. And I want to discuss the occlusion process now as well in identifying these events. This is from the video that I just showed you. There you can see that occlusion. Let me pull off my head a little bit as well. And I'm going to open this up and try to annotate this image here really quickly. But there you can see that clear slot. And they look similar in structure to a regular supercell storm. In addition, sometimes when these QLCS tornadoes do form, they will get a little bit of a dust wear on the back side as well that I noticed. And I'm going to show you some similarities to some of these other QLCS tornadoes that I've intercepted over the years. But this occlusion was just to the east of Norfolk, and we deployed some gravitron sensors in the path of this occlusion, and it passed over. I still need to send all of that information off to Mark so that we can assess some of the gravity waves that were developing along that rapidly advancing arc that was moving at speeds of up to 90 miles an hour. Let me pull up this occlusion here and annotate that image. I am going to be heading up to the damage path. I'm going to be heading up to that damage path as well to bring a truckload of supplies up to the damage. Thankfully, Flex Tape has given me some resources so that I can pick up some of these supplies and then head up. I'm going to go to a drop-off point up in Kentucky. That's what I'm going to be working on this weekend. Trying to get this occlusion pulled up. so that we can break it down. I know where it is. It's under the screenshot area here. Got a lot of different files. Satellite images as well. Omaha is also going to be out sampling this damage, including that tornado that happened just to the west of the Bancroft area. And here is the typical QLCS type tornado structure that I observed. This was in Meridian, Mississippi back in 2018. This was also rated an EF2 tornado. And notice how there are those two debris plumes. The parent vortex is out front. That's on the right side of your image. And then you get a little bit of a plume on the back side. That's a rear inflow jet. Very compact structure here. A little bit of a clear slot aloft at cloud base. Additionally, I'm going to go over that clear slot here next. But interestingly, I noticed that a lot of those tornadoes that happened into western Iowa and in eastern Nebraska, some of the photos that I've seen, they kind of show that dual structure where you have a little bit of a debris puff underneath the parent vortex and then a bit of a rear inflow jet, gustnado, on the backside feeding into that. And you get damaging winds with that parent vortex and with that rear inflow jet that feeds right into the backside. And interesting, I did see a similar structure out there while we were storm chasing. There it is. Just pulled up our screenshot here so I can break down this occlusion process. This was a Meridian tornado back in 2018. So this is the annotated. It only let me pull up one at a time on these dells. But at least I can annotate the image for you and break down the occlusion process. Oh, you gotta be kidding me. Well, oh, I see what's going on here. Stand by. So basically what happens is you can see that contained rain curtain right in the middle. You can also see the gust front out in front of it a little ways. And what happens is these kinks will close up and then you get an occlusion process where you get the dry air wrapping all the way around. It's often associated with rain curtains. It will enclose that inflow air inside and then you get a vortex. And it's underneath an updraft, a tilted updraft that may or may not be a mesocyclone in these QLCS cases. Oftentimes you get tilted convection up above, and then you get a little occlusion or a little dry slot that cuts in there, stretches that vortex into the vertical. You have rain curtains that will wrap around. Sometimes they can tighten up to really damaging tornadoes as well. And first I want to show you these on radar. So here you can see a couple of those occlusions on radar. This is from Eric Kelly, who was out there storm chasing. We were on that parent circulation off to the west, a little bit to the west of that. That ended up being a damaging tornado that crossed Highway 51 just to the east of Wisner by about 10 miles. National Weather Service Omaha is going to be out sampling that tornado. It snapped about 4 power poles right at the base. All those power poles were laying down. And interestingly, these really fast-moving QLCS tornadoes like this basically behave like a knife on their eastern side. And on the eastern side of these tornadoes that are moving at 90 miles an hour, you add the storm motion to it. So imagine a tornado vortex that has 60-mile-an-hour winds that are spinning around uniformly. and then you attach a motion to that vortex, 90 miles an hour off to the northeast. You add those 90 mile an hour winds to the southeast side of the vortex, you subtract that 90 mile per hour motion from the west side, and basically what you get is a tornado that's very strong on the east side, capable of EF2 damage or even greater than that. And then on the west side of the circulation, you get relatively weak winds. And this is all along that gust front. There you can see the gust front where the red meets up with the pink color, but then you get the couplets along it. Multiple circulations along that gust front. We intercepted about 3 or 4 of these as we were moving from west to east along the northern edge of that front. And this is one of those circulations. This is just to the west of that tornado that passed near the Bancroft area. I did it. I can finally annotate this. I'm still getting used to the new Dell setup here. I'm definitely used to the Mac operation. In general, I need to upgrade all of my equipment, including my potato phone. I do, however, have these awesome Crocs. Check out these Crocs with the lightning bolts on them. These are going to be my new storm chasing shoes. Thank you to Santa Claus for these. My mom. Storm chasing Crocs. These are going to be fun with those lightning bolts. Crocs are kind of my go-to footwear when I'm out there storm chasing, and I finally have this image up and I'm ready to annotate it. So there it is, everybody. There is the occlusion. Really what happens is this air descends on the backside as an RFD, and then it wraps out front like this cyclonically, and you can see those rain curtains as well in there. That creates a spin, and you can see that vortex. Similarly, when you're chasing a regular supercell and you're looking at a mesocyclone, you look for these clear slots that will punch into the base and then tighten up a tornado cyclone at the low levels. This is called the occlusion process when it wraps all the way around, and you're basically forming vortices at lower scale here. So at a smaller spatial scale, you have a much larger mesocyclone, a tilted one that's rotating up above it. And if it becomes strong enough, you get cross isobaric flow. The rear flank downdraft that's descending back behind this updraft will wrap up in the front, tighten up that circulation. And you can see all these rain curtains underneath it as well. You can see the motion in there, the left to right motion looking off to the south. So those are easterlies that are wrapping around this circulation. I do believe that these are occluded at a certain level up above, and then you're getting surface inflow at the low levels, and eventually when these rope out and weaken, you're even cutting off that surface inflow, and the occlusion is complete from the surface all the way up, extending up into the atmosphere. But when these tighten up, that's when you can get damaging tornadoes in there, sometimes 2 vortices right next to each other, one in the front, a little trailing inflow jet as well. But this is looking off to the south at that occlusion that's forming, and these are what we were trying to deploy along as we were going west to east along that road, looking off to the south. I was trying to face off to the south with my live streaming camera to show you that. We did deploy on 2 of these, flex taping those to poles out in advance of these tornadoes. But I am excited to look at some of that data, because when a tornado cyclone like this passes over our high resolution microbarometer network, you're going to be able to see those gravity waves moving through the network. You're going to see the pressure fall as that tornado vortex moves over it. But that in general is how you get an occlusion. There you can see the occlusion now without all of the annotations. But it's pretty difficult. It definitely takes a trained eye to pick these out when you're looking off to the south. But if you chase a couple of these derecho events, then you definitely do start to figure them out quite rapidly. And you can see that gust front right along the leading edge of it. That gust front, that extends all the way along the arc. So along the entire arc, you'll see that gust front. And then you get these little circulations that will form inside of it. There you can see that those converging winds. That's the advancing arc. And then you get those circulations. The pink and orange color is wind away from the radar. So this is using Omaha radar off to the southeast. So that shows you the strong southerlies on that east side of the circulation, where you add the storm motion speed to the derecho. And I think these QLCS regimes, even though they are relatively linear, I still think that they're composed of embedded supercells. And the RFD on the south side of each of these circulations is a little bit more elongated, and everything is connected together. But if anything, the whole QLCS can even force a further right storm motion than you would have had if it was just an individual tornado. And I think that that helps make the streamline's vorticity intake just a little bit greater as well. This is the RAP analysis leading up to the event, just as the arc was forming in south central Nebraska, north central Kansas. And I want to show you why the elbow was a favorable target in this one. And then this is the shear as the arc ejected to the east, eventually as it was into western Iowa. And notice how those higher values are coming into the south, into southwestern Iowa. And then the storm relative helicity, the effective storm relative helicity, decreases as you go up above the elbow. As you wrap around the north side of that arc, it's decreasing. If you had a closed 850 low at a slightly more favorable trough shape, then you'd be wrapping that shear all the way around the arc, and you'd actually have increasing shear as you go further north because of the increasing easterly component to the low-level winds to the 850 low. But because that 850 low was also in the process of closing up as the system was ejecting, most of the stronger shear was nosing right up into the Omaha area, right up to that elbow. Initially, we targeted the early elbow there to the south of the Norfolk area. Those were those early tornado warnings. One was looking just to the southwest of the Norfolk area, that where you could see closed rotation. That one spun off to the left. And so the instability wasn't quite as favorable either off to the northwest of the arc, but mainly it was a shear issue with a little bit with decreasing shear as you go further north and northwest around that arc, as opposed to increasing shear as you often see with a more closed 850 setup. Instability definitely was not an issue with this setup. You had dew points even into the low 60s there into western Iowa. This time of year is insane. Chasing this tornado event with snow piles on the ground reminded me a lot of that April 9, 2011 event, which was also a potent negatively tilted trough punching into the Corn Belt or the upper Midwest, except that it was during April, so you had much more favorable thermodynamics then, and you had that outbreak that happened during the overnight across northern Iowa, including the Mapleton, Iowa tornado. In this case, I think if you had a slightly more closed 850 low, then you'd have more discrete supercells to the north of the elbow as well. But you can notice how that instability and the convective inhibition increases as you go further to the northwest around that arc additionally. So if you had a more closed 850 low, you would have been wrapping that moisture right around the north side of the arc as well. Here's that 850 loop showing how that low-level jet, this is the 1 kilometer wind, see there's the big winds ejecting. But notice how that 850 low never really closes off. There it tries to close off, but it's just too late. You had most of those just southeasterly, rapidly ejecting low-level jet off to the northeast rather than closing up. If it was a slightly slower system, then I think it would have had a chance to close up that 850 low and wrap that instability around the north side of the arc. And then there likely would have been even more tornadoes to the north of that pivot point. But there you can see that trough ejecting. Quite an unprecedented event with haboobs, wildfires, snow squalls. And I actually was chasing tornadoes in the Norfolk area. And then when I came back to recover the gravitron sensors, a snow squall moved in just 2 hours after those tornado warnings were happening. Which is just incredible. But the models did a great job on this event leading up. We are in a very record-breaking December for tornadoes. And there's a slight risk today that just came out for southeastern Oklahoma, just to the southeast of Norman, including a 2% tornado probability. We're going to go over that as well right at the end of this outbreak. I know this is a little bit long, but we have a lot of things to cover during this insane December. And I also want to show you some of the damage surveys from the National Weather Service Des Moines. I also wanted to discuss the damage surveys from the December 10, 2021 event. So just as we suspected, noting that cycle in northwestern Tennessee, it does appear that it was not a record. I still think it was a record because I believe that the quad state tornado likely cycled, or the tri-state tornado likely cycled as well. Back in 1925, we just don't have the technology to really resolve many of those cycles. So I think that the tri-state tornado also cycled, and a 219-mile path might be a bit of a stretch. This one had a quick cycle on December 10, 2021 in northwestern Tennessee, as we saw in our briefing, our recap of the super tornado. Both of those two long track tornadoes are rated EF4. The one that went through Monette Leachville up to south of Hayti. That was rated an EF4 with 170 mile per hour winds estimated. And then the next EF4 touched down right at the Kentucky-Tennessee border, raced off to the northeast with an even longer path. That was a slightly stronger tornado according to the damage survey, with max sustained winds estimated at 190 at the worst of the damage. The wind estimates, I'm a little bit, I think that those are a bit problematic because you're assuming that damage occurs almost instantaneously when that wind hits. And I've noticed that there was some comparison with the damage to those big tornadoes, destructive tornadoes in the Great Plains. And I think that you have to realize the differences physically between those two tornadoes. Tornadoes in the Mid-South or Dixie Alley, a lot of times they're moving 40 to 60 miles an hour, 50, 60, 70 miles an hour. They're moving really fast. So the residence time of those destructive winds at any given point along the ground is a lot less. Realizing that fast storm motion does add the storm motion on the south side of the tornado, it's still moving faster and almost makes it more of an effective straight line wind, where you're adding the wind on the southeast side of the tornado. In the northwest, you're subtracting that storm motion. So you're having a little bit less variation in the acceleration of the overall wind flow as opposed to a stationary tornado. So imagine if you have a stationary tornado and a fast-moving tornado of the same strength, assuming both have 180 mile per hour winds. The stationary tornado, the winds are constantly accelerating. Those wind speeds of 180 mile per hour in magnitude are constantly changing direction, subjecting every structure on the ground to rapidly, constantly accelerating winds of different direction at all times. Those winds are also hammering those areas about 5 to 10 times longer in duration with those near stationary tornadoes as compared to a fast-moving one in the Mid-South. That also is a big deal. I think the residence time of those damaging winds over any given point on the ground is why you see such immense destruction with those tornadoes like May 3rd, 99, or especially the Gerald, Texas tornado, which was moving at about 10 miles an hour. Then you take these tornadoes in Dixie Alley that are assumed to have lower wind speeds because the damage doesn't look as substantial. Also, the engineering of those homes isn't as robust. The anchor bolts are a lot of times detached, or sometimes they're attached to concrete-filled cinder blocks. So that's why it's comparing the wind estimates. I think that you also need to factor in the residence time of those winds at any given point. And I don't know how you'd accomplish that. I definitely support the experts that are on the ground coming up with these ratings. I support the EF4 rating for this tornado within the context of the enhanced Fujita scale. But I do think that the scale could be improved. Maybe you can correct some of the damage estimates for the estimates of tornado strength based on the damage estimates using the dual pole data and how high the debris gets lofted up into the atmosphere. Is it lofted up over 30,000 feet with the rotational velocity supporting a stronger tornado than what the damage is indicating or what the engineering can allow for in the damage survey? But either way, it does feel a little bad splitting hairs like this between an EF4, EF5 tornado when both of those types of tornadoes are so disruptive to so many lives, causing so much loss of life out there as well. But it's important for the scientific database to have a good damage scale to look back at these events and realize just how significant an event like this was. But this tornado was so long track, it impacted multiple communities along its path. It was like Joplin, Missouri, just right down its path multiple times, each city from Mayfield to Bremen to Princeton, Kentucky, to Benton to Bowling Green. The Bowling Green tornado did get a preliminary EF3 rating. So far, it was originally given an EF4 that was leaked on the website. That has been downgraded more to an EF3, also due to the engineering of those structures. A lot of those anchor bolts not drilled in to that. But now the experts at the National Weather Service are surveying the events from the derecho. I saw National Weather Service Omaha is heading up to the west of the Bancroft area to survey those. But incredibly, these tornadoes were moving at speeds of over 100 miles an hour in western Iowa, estimated. So the path length was 26.1 miles. It did that over the course of 18 minutes. So that tornado was actually hauling ass. Maybe one of the fastest tornadoes ever documented. And it's not surprising that it was given an EF2 rating. Even a vortex with 20 mile per hour winds that's moving at 100 miles an hour is going to produce 120 mile an hour winds on its southeast side. That's also why those tornadoes often looked quite wispy out there, not fully condensed all the way to the ground because they weren't necessarily associated with a really dramatic pressure fall to get that condensation all the way to the ground. So they're just this dust swirl or a fast moving windbag type deal. But really the actual vortex, when you view it in a storm relative sense, moving along with the rapid motion of that storm, the vortex overall is relatively weak. But when it's something that's moving at 100 miles an hour, you have to add the 100 mile per hour winds to one side of the tornado, subtract those 100 mile per hour winds from the other side of the tornado. And these are some of the tornadoes that were analyzed. It's not surprising that pretty much every one of these tornadoes is rated an EF2, because a tornado that's moving at 100 miles an hour does not have to be that strong to produce 120 mile per hour winds on the southeast side. In fact, any tornado, any damage probably had at least 120 mile per hour winds out there. A lot of it is common sense, these damage surveys. When you kind of think about a stationary tornado versus a rapidly moving tornado. But really the enhanced Fujita scale is designed to take that subjectivity out of it, add some objectivity with working with engineers and break down the quality of the engineering of the home, the anchor bolts, the foundations. But I think that in these really rural areas where the engineering of the homes maybe isn't the same as some of the richer areas, I think that you could possibly find some other indicators that can support ratings that would be more representative of the tornado strength. But at the same time, these scientists have very difficult jobs out in the field, and it's important for us to be very supportive of them as they're out there working so hard to do such important work as well. So now I'm going to go back and play some of the video that we captured from the QLCS tornado. And then I'm also going to break down the slight risk. In fact, we should probably do that right now, because this is new breaking news down into southeastern Oklahoma. Even some flash flood watches down there. 2% tornado probabilities issued by the heroes of the Storm Prediction Center. Absolute heroes of humanity over at Storm Prediction Center and the National Weather Service issuing those warnings. We celebrate the National Weather Service here at Team Dominator headquarters. But there you can see the 2% down there. A little avocado without an avocado core. But there you can see that. And let's take a look at the RAP analysis here and see how the conditions are evolving down into southeastern Oklahoma. We have some decent instability starting to bubble up. Look at that, 1 to 2,000 Cape. There's also a boundary here, and it's not a surging boundary. Notice how the winds on the other side of that boundary are relatively weak. Anytime you get a boundary like that, you can get near calm winds, and so if you do have just a little bit of a low-level jet above that, then you could get a tornado threat. And look at southeastern Oklahoma. Just get a couple bubblers of some storms developing right along that boundary. Could also be some flash flood potential southeastern Oklahoma into western Arkansas. Let's take a look at the effective storm relative helicities with time. Not bad, 200 plus down there into southeastern Oklahoma. So I could easily see tornadoes happening southeastern Oklahoma into western Arkansas with this event. And in fact, I think storms are already starting to develop. Let's take a look at these storms. Pulling up the radar. Now this is a long-winded briefing, but I move slow. I'm getting old. So I'm going to pull up the radar here and break down exactly what is happening. Gotta be kidding me. First, let me play this other video. Got it. And it was great teaming up with Mike Lashendro on this chase of the Omaha Twister Chasers. Hopefully you enjoyed his commentary out there. It used to be formerly of the Omaha Twister Chasers, now Nebraska Storm Chasers. And here you can see, looking back to the southwest at that storm. This was just to the south of Norfolk. This is our first deployment location. You can see what appears to be some haziness right in the middle of that. I thought that was definitely a circulation, probably even a QLCS tornado in that area. We could have driven south and deployed on that. I think that tornadic circulation went right over the gravitron. And then look at that little bird fart right near the ground. You can see that little dot. Little dust swirl right in the backside. Maybe a tornado back behind that gust front with the remnants of a rear inflow jet feeding into it. And then you can see those snow piles on the ground, too, just to the south of Norfolk. Then we went to the east of Norfolk and then saw all those circulations off to our south, wrapping up those occlusions, each one of those one after another. And that's when we deployed the two gravitrons. Let's see if I can pull up the radar. Just not as quick working this PC as compared to the... Come on. But look at the lightning. The lightning was just incredible with these storms. Spider lightning, almost like anvil crawlers at the low levels, and that's because the updrafts were so tilted. Grapple and hail generation was immense. That's what contributes to that charge separation within a storm. A lot of cold air aloft, some dry air intrusion also in there, helping to create those hail sizes. And then we're pushing off to the east here in Norfolk, getting ready to deploy the gravitron data. I'm excited also to share, there's off to the southeast, one of those developing QLCS circulations. We went over that occlusion. You can see the sinking air back behind it, trying to wrap around that lowering. That's the wall cloud that produced a damaging tornado to the west of Bancroft, and we made a bit of a navigational error, turned off to the southeast instead of going due east, or else we would have seen that. There's that occlusion. Look at that little bulb right in the middle, that little button back behind the rain curtains. You can tell it's a little bit fuzzy. That means that the rain curtains are wrapping around that circulation, making the circulation a little bit fuzzy back there. That's probably a tornado, and it did cause some damage down to the south. These things just don't condense like you'd see because they're not associated with a big pressure fall. They're relatively weak tornadoes, but they're moving so fast that you add the storm motion on the one side, and it basically turns into a knife just cutting across the ground. There you can see those rain curtains circulating there. That's what we say when we say an occlusion to the southeast, occlusion southeast. That basically means that dry air sticking around the backside, helping to enclose that inflow of the tornado vortex. See if there's any tornado warnings happening right now. They're just starting to bubble down into southeastern Oklahoma, but I'm going to keep an eye on that event. You have 200 plus 0 to 1 kilometer storm relative helicity. I say that the chances are pretty good of a tornado warning or two later on this afternoon over southeastern Oklahoma. I'll do some radar breakdowns for everybody additionally as that event moves through. But thank you for following me live as we were chasing down this event. You had the arc of fast-moving supercells on the front edge. You had that sting jet back behind it, a little haboob around that into southwestern Kansas. And then you had those fast-moving wildfires into north-central Kansas, also back toward Guyman into the Panhandle region, doing damage to the north of Russell. And then you also had the downslope mountain wind event up in the foothills of Colorado and New Mexico. Pueblo had winds gusting over 100 miles an hour. I saw some structures even rolling inside of those winds. So definitely an unprecedented event for December. Pretty classic, though, for the negative PDO with a lot of cold water in the northeastern Pacific. Definitely not surprising that this event happened. So I'm going to keep updating you. If those tornado warnings get issued in southeastern Oklahoma, I will go live. Mark my word on that. And keep watching this because right at the end of the tornadoes, or this tornadic potential, that was when the snow moved in and snow squalls came in as I was recovering that gravitron network. And I will go live and share the gravitron data as well with you. Gravitron, there you can see some of the tornado damage also that we saw to the northwest of Omaha that National Weather Service Omaha is surveying today. Look at all the corn stalks just sitting inside of those bushes there. There was a harvested or a field where all those were cut off and just blew around. I think you got a little wake eddy right into that valley. Definitely some big winds. Power flash there on the right side. Arcing action happening. Snow piles, tornado warnings, absolutely insane. So thank you everybody for tuning in to this weather report. Much more to come. Hopefully you enjoyed this analysis. Sorry if it was a little bit slow. I'll get faster as I'm moving, as I start to get used to this system. May need to try some new streaming software as well so I can annotate right on top of this, just draw right over the stream. So thank you everybody for tuning into this. Never stop chasing. Enjoy the rest of this video.
Steady. Wow, look at those trees. They're about to... Cars pulled over on the side there. Wait, I got debris on the right. I got debris on the right.
Really?
Yeah. Wow. Careful. Careful. Car coming up.
Whoa, that was a big pull. Did you feel that?
I felt that. What do you think that was?
Felt like a little mesoport.
It's like nighttime. Four-way stop.
Pilger.
Pilger. Four-way.
I think that's blinking yellow.
That car is still up there. Semi coming. Wow.
Yeah, big time win.
I think I see that car. Bridge coming up.